Okay. Today we are going to discuss how to evaluate real integrals using complex residue integration or complex integration. So first we consider the case a complex integration of the form integral 0 to 2 pi a function of cos theta sin theta d theta. Okay, it's a function of cos theta and sin theta. An integral from 0 to 2 pi. So first next we are going to convert this integral in a complex form by substituting z is equal to e raised to I theta. We know that e raised to I theta is cos theta plus I sin theta, isn't it? Cos theta e raised to I theta is cos theta plus I sin theta. It's a complex number. So let it be z. So z is equal to e raised to I theta. I theta. This is our substitution. Okay, this is our substitution. Then what happened? Then cos theta is of the form 1 by 2 e raised to I theta plus e raised to minus I theta. Why? We know that e raised to I theta equal to cos theta plus I sin theta. And similarly, what about e raised to minus I theta? That is nothing. Cos theta minus I sin theta. So by taking the sum of e raised to I theta plus e raised to minus I theta, this become 2 cos theta. So that's why there is a by 2. So cos theta plus e raised to minus I theta by, e raised to I theta plus e raised to minus I theta by 2 is cos theta. Okay. So this is cos theta. So what about our z? Z is e raised to I theta. So what about 1 by z? So what about 1 by z? That is 1 by e raised to I theta, and this is nothing e raised to minus I theta. So if z is e raised to I theta, then 1 by z is e raised to minus I theta. Okay, so this is our z, this is 1 by z. So now we can convert cos theta in terms of z. Okay, so we can write cos theta as 1 by 2 z plus 1 by z, where z is e raised to I theta. Okay, so this is the first conversion of cos theta in terms of z. Okay, similarly we can find sin theta. What is sin theta? If you take the difference between these two, we consider e raised to I theta minus e raised to minus I theta. What happened? If you take the difference, this cos theta became cancelled, and this is I sin theta plus I sin theta, that is 2I sin theta. So what about sin theta? Sin theta is equal to e raised to I theta minus e raised to minus I theta minus e raised to minus I theta divided by 2I. Okay. So sin theta become sin theta become 1 by 2I e raised to I theta minus e raised to minus I theta. And we know that e raised to I theta is z. This is our 1 by z. So sin theta in terms of z, that is 1 by 2I z minus 1 by z. Okay. The procedure is, so first we substitute z equal to e raised to I theta, then we convert cos theta and sin theta in terms of z. Okay. Next one, we have to convert this integral in terms of z. So we substituting this cos theta by this term and sin theta by this term. So this f of cos theta sin theta is a function of z. This become a function of z. Okay. So what about d theta? To find d theta, you consider derivative of z with respect to theta. So dz by d theta is equal to I e raised to I theta. That is the derivative of e raised to I theta, isn't it? So this implies d theta is equal to dz by I d. Okay, this implies d theta is nothing. D theta is what? dz by I e raised to I theta. But we know that e raised to I theta is z. That's why this is equal to dz by iz. Okay, so d theta equal to dz by iz. Okay, അപ്പോൾ ഇസഡിന് ഇ റേസ് ടു ഐ തീറ്റ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തിട്ടുണ്ടെങ്കിൽ കോസ് തീറ്റ ഇങ്ങനെ കിട്ടും, സൈൻ തീറ്റ ഇൻ ടേംസ് ഓഫ് ഇസഡ് ഇങ്ങനെ കിട്ടി. സോ നെക്സ്റ്റ് ഇവാലുവേറ്റ് ഡി തീറ്റ ഇൻ ടേംസ് ഓഫ് ഇസഡ്. ഓക്കെ, വി ആർ ഗോയിങ് ടു കൺവേർട്ട് എവറിത്തിങ് ഇൻ ടേംസ് ഓഫ് ഇസഡ്. എല്ലാത്തിനെയും ഇസഡിലോട്ട് ആക്കാൻ പോകും. സോ ഡി തീറ്റ ഈക്വൽ ടു ഡി ഇസഡ് ബൈ ഐ ഇസഡ്. അവിടെ വരെയായി. നെക്സ്റ്റ് വൺ, വാട്ട് അബൌട്ട് ദിസ് റേഞ്ച്? How to convert this range in terms of z? Okay, we know that z is equal to e raised to I theta. Okay, so what about modulus of z? Whatever be the value of theta, e raised to I theta has a property. What is the property? This is the property. Okay, whatever be the value of theta, you consider the mod z. Whatever be the value of theta, you simply consider mod z. Mod z means modulus of e raised to I theta. And we know that e raised to I theta is, equal to cos theta plus I sin theta, right? So what about
class in the record you?
Eda?
Class in the record you?
Recording. OBS recording. Okay. So e raised to what is our e raised to I theta? E raised to I theta is equal to cos theta plus I sin theta. Okay, so what about the modulus of e raised to I theta? We know that modulus of a complex number is square root of x square plus y square. So here this is the role of x, this is the role of y. So that's why mod z is equal to square root of cos square theta plus sin square theta. Right, and we know that cos square theta plus sin square theta is always 1. So its positive square root is 1. So mod z is always 1. Geometrically, what is mod z equal to 1? Geometrically, what is mod z equal to 1? We know that mod z equal to 1 is a circle with the center 0 and radius 1. Okay, next question, what is the orientation of this curve? What is the orientation of this curve? Is positive orientation or negative orientation? Actually, this is a positively oriented curve. That is because whenever theta is varying from, suppose theta is varying from 0 to 2 pi. Whenever theta is varying from 0 to 2 pi, this e raised to I theta is moving like this. This e raised to I theta is moving like this in anti-clockwise sense. Okay, so whenever theta equal to 0, you see this. Whenever theta equal to 0, this is 1. So z equal to 1, this point. Similarly, if theta is increasing, suppose theta equal to pi by 2, that is e raised to I pi by 2. What is e raised to I pi by 2? Cos pi by 2 plus I sin pi by 2. We know that cos pi by 2 is 0, right? Cos pi by 2 equal to 0 and sin pi by 2 equal to 1. So e raised to I pi by 2 is I, because cos pi by 2 plus I sin pi by 2, cos pi by 2 is 0, sin pi by 2 is 1. So e raised to I pi by 2 is equal to I. So this is the point I, right? So whenever theta is moving from 0 to 2 pi, our curve is tracing in anti-clockwise sense over mod z equal to 1 or positive sense. Okay, so as a conclusion, what about this integral? Now this integral is of the form integral. What about this inside function f of cos theta sin theta? Now cos theta and sin theta both are in terms of z. So ultimately the whole function becomes some function of z. Whatever be the value of the function, anyway, after simplification, this is a function of z alone, isn't it? And what about d theta? We know that d theta equal to dz by iz. So this is dz by iz. Now everything is in terms of z. Okay, next one, what is integral? Integral over which curve? What is integral over c? What is c? We know that whenever theta is varying from 0 to 2 pi, our curve z is moving along the curve mod z equal to 1 in anti-clockwise sense. So c is nothing, mod z equal to 1 in anti-clockwise sense. Mod z equal to 1 in anti-clockwise sense. Okay, now this is our normal contour integration, our complex integration, because this mod z equal to 1 is a simple closed curve. ശരിയല്ലേ? mod z equal to 1 എന്ന് പറയുന്നത് ഒരു simple closed curve ആണ്. Okay, we know that how to integrate over a simple closed curve using residue theorem. That is the importance of residue theorem. We can evaluate this type of real integrals using complex residue theorem. Okay, and we know that this is equal to 2 pi I into sum of the residues where the summation runs over the singularities inside the curve C. സിയുടെ അകത്തുള്ള സിംഗുലാരിറ്റീസിലൂടെ വേണം നമ്മൾ ഈ സമ്മേഷൻ റൺ ചെയ്യാനായിട്ട്. ഓക്കെ, സോ ദിസ് ഈസ് ദ ഐഡിയ. സോ ഓക്കെ, ദിസ് ഈസ് ദ കൺക്ലൂഷൻ. So what is the conclusion? Integral 0 to 2 pi f of cos theta sin theta d theta equal to integral over C f of z dz by iz, where C is the unit circle, mod z equal to 1, counterclockwise. ഈ കൗണ്ടർ ക്ലോക്ക്വൈസ് ഇമ്പോർട്ടൻ്റ് ആണ്, ബിക്കോസ് ഇത് കൗണ്ടർ ക്ലോക്ക്വൈസ് ആണെങ്കിലാണ് യു ക്യാൻ യൂസ് അവർ റെസിഡ്യൂ തിയറം. ദറ്റ് ഓൺലി ദിസ് ഈസ് ഈക്വൽ ടു 2 pi I into sum of the residues. Okay, sum of the residues of the function. Here our function is nothing, our function is f of z by iz. Clear? So in this case our integrand is not only f of z by iz. That is the integrand. Okay, so using residue theorem, this is equal to 2 pi I into sum of the residues of f of z by iz, where the summation runs over the singularities inside this curve C, inside the curve mod z equal to 1. Clear? So ഇതാണ് ആദ്യത്തെ ഒരു ഇൻ്റഗ്രൽ. നമുക്ക് രണ്ട് ടൈപ്പ് റിയൽ ഇൻ്റഗ്രേഷൻസാണ് ഉള്ളത്. ഇതാണ് ഫസ്റ്റ് ടൈപ്പ്. ഇതിൽ എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിച്ചോ. Any doubt, then you ask me. Otherwise, we'll move to a problem. Okay, so this is the theory behind this type of integrals. So consider a problem. നിങ്ങൾ തന്നെ ചെയ്ത് നോക്കിക്കോ ഈ പ്രോബ്ലം, എല്ലാം നിങ്ങൾക്ക് ക്ലിയർ ആണല്ലോ. So evaluate integral 0 to 2 pi d theta by square root of 2 minus cos theta. Okay. Now it is clear that this is of the form our previously discussed case. Then for simplicity, what is our f of cos theta sin theta? ഞാൻ വെറുതെ ചോദിക്കുകയാണ്, നിങ്ങൾക്കൊരു ക്ലാരിറ്റി കിട്ടാൻ വേണ്ടിയിട്ട്. ഫസ്റ്റ് പ്രോബ്ലം ആയതുകൊണ്ട് ചോദിക്കുകയാണ്. Comparing to our theory, what is our function? What is f of cos theta sin theta? Comparing to our
1 by root
yes
2 minus cos theta.
Yeah, 1 by root 2 minus cos theta. Comparing to our standard form, here f of cos theta sin theta is nothing, it is 1 by root 2 minus cos theta. So our aim is to convert this function in terms of z. So its procedure is we substituting z is equal to e raised to I. This is the procedure. Okay, then we know that what about our function? So our function 1 by root 2 minus cos theta is nothing, or you can directly write the integral. Okay, the integral is integral mod z equal to 1 1 by square root of 2 minus, we know that cos theta is 1 by 2 z plus 1 by z. This is the value of the cos theta in terms of z, right? And what about d theta? D theta is dz by iz. അപ്പോൾ ഇതൊക്കെ നിങ്ങൾക്ക് ബൈ ഹാർട്ട് അറിയാമെങ്കിൽ ഡയറക്റ്റ് ആയിട്ട് എഴുതാം. അതെങ്കിൽ യു ക്യാൻ ഡിറൈവ് വാട്ട് ഈസ് cos theta and sin theta, then you substitute. Okay, then upon simplification, what happened? This become integral mod z equal to 1 by, and this is our root 2 minus, you can take the LCM. So this is 1 by 2 z square plus 1 divided by z by taking the LCM, right, into dz by iz. Okay, again you can take another LCM because now here denominator is 2z. So again you take the LCM, then this integral become integral mod z equal to 1 by, this is 2z, so this term become 2 root 2 z, right, minus this is z square, and this become minus 1 divided by 2z dz by iz. So you can cancel this z, then the remaining term, okay, this become, actually this is of the form 1 by a by b form. So this is nothing b by a. So we can write this as 2 by like this. So 2 by I is a constant, so you can take outside. So this becomes 2 by I integral over mod z equal to 1 by, okay, for converting in standard form you can take a minus outside, so this becomes minus of z square minus 2 root 2 z, and this become plus 1 dz. Okay, so again you can simplify. So this minus is common, we can take outside. So this become minus 2 by I integral over mod z equal to 1 by z square minus 2 root 2 z plus 1 dz. Okay, so our real integral, actually this is our real integral. This real integral is like this after the substitution. Then upon simplification we get this is like this. Now this is our simple contour integration, complex integration. Okay, so how to integrate? Okay, we know that its integral value is equal to 2 pi I into sum of the residues, where summation runs over the singularities inside the curve C. Here our curve is nothing, mod z equal to 1. So this is our curve C, mod z equal to 1. Okay, so what are the singularities inside this curve? So we have to find what are the singularities of this function inside this curve. To find the singularities, we equating the denominator as 0. So by solving the denominator, that means z square minus 2 root 2 z plus 1 equal to 0. Then what are the roots? Z is equal to minus b, that is 2 root 2 plus or minus square root of b square minus 4ac. Here b square is 4 into 2, that is 8, right? Square of 2 root 2, that is 8. 8 minus b square minus square root of b square minus 4ac. So 4ac is 4 itself, divided by 2a. So here a is 1, so this is 2. Okay, so this is 2 root 2 plus or minus, this is square root of 4, that is 2. So 2 by 2, so this is equal to 1 2 is common, you can take outside and cancel. So this become square root of 2 plus 1 comma square root of 2 minus 1. So these are the singular points. These are the singular points of this function, right? This entire function, this is our function. Okay, so these are the singular points of this function. It is clear that they are simple. They are simple poles because they are simple zeros of the denominator function. We know that if z0 is a simple zero of a function f of z, then they are the simple poles of its reciprocal. Okay, so it is clear that they are the simple poles of this function 1 by z square minus 2 root 2 z plus 1. Okay, the next question, which singularities lies inside the curve C? Which singularities lies inside the C? What about root 2 plus 1? ഈ root 2 plus 1 ഇതിൻ്റെ അകത്തുണ്ടാവോ? This is mod z equal to 1. Is this root 2 plus 1 belongs to C? Inside C?
No.
No, because we know that root 2 is approximately 1 point something. So this total value is 2 point something. So 2 points, this is only 1. So this is 2. So 2 point something is somewhere here. So it is clear that root 2 plus 1 is outside the curve C. Then what about root 2 minus 1? Is it in?
Lies inside C.
That is inside C, because we know that root 2 is approximately 1.41 etc. Okay, anyway its difference is root 2 minus 1 is approximately minus 0.41 etc. So anyway this is somewhere here. So this is our root 2 minus 1. So root 2 minus 1 inside C and root 2 plus 1 outside C. So we have to find only the residue at root 2 minus 1. We are not interested on root 2 plus 1 because it is outside. Okay, so next our aim is to find the residue of this function at root 2 minus 1. Okay, so what is the residue? So what is residue at z is equal to root 2 minus 1 of the function f of z? Okay, in our case f of z is this is our f of z, right? And the f of z, so this is our f of z. Okay, we have to integrate over this function. Okay, so this is equal to now kind of formula simple direct it is a simple pole, so limit z tends to root 2 minus 1 z minus z naught, so root 2 minus 1 into 1 by, you can factor this polynomial as z minus root 2 minus 1 into z minus other factor is root 2 plus 1, root 2 plus 1. Okay, so you can cancel these two, so this become, and we substitute this value, you get the limiting value, so this become 1 by, but this is equal to 1 by whenever result is equal to root 2 minus 1, so this is root 2 minus 1 minus root 2 plus 1, right? So this is equal to, you can cancel these two root 2, so what happened, this is 1 by minus 1 minus 1, that is minus 2, so minus 1 by 2. So minus 1 by 2 is the residue at z equal to root 2 minus 1, right? So minus 1 by 2 is the residue at z equal to root 2 minus 1. And we know that this is the only one singularity inside the C. So you can easily evaluate this integral using our residue integration. So by residue integration, what about this integral? Minus 2 by I is common, so minus 2 by I into, what about this integral? This integral value is equal to, this integral value is equal to 2 pi I into sum of the residues inside C. We have only one residue, so what is the residue? Minus 1 by 2. So this is equal to minus 1 by 2. Okay, so this become, we can cancel these 2 and this is 2 by I, so we can cancel this I, and the remaining, this minus is plus, so ultimately this is equal to 2 pi. So this integral is 2 pi. Okay, so this is the technique. So this type, the integral of the form 0 to 2 pi some function of cos theta sin theta, ആ ടൈപ്പിൽ വരുന്ന റിയൽ ഇൻ്റഗ്രൽസിന് കോംപ്ലക്സ് റെസിഡ്യൂ ഇൻ്റഗ്രേഷൻ ഉപയോഗിച്ച് ചെയ്യാം. അപ്പോൾ എൻ്റെ പ്രൊസീജിയർ ക്ലിയർ ആയെന്ന് വിചാരിക്കുന്നു. ഫസ്റ്റ് വി കൺവേർട്ട് കോസ് തീറ്റ ആൻഡ് സൈൻ തീറ്റ എവറിത്തിങ് ഇൻ ടേംസ് ഓഫ് ഇസഡ് ബൈ സബ്സ്റ്റിറ്റ്യൂട്ടിങ് ഇസഡ് ഈക്വൽ ടു റേഷ്യോ ഐ തീറ്റ, ദെൻ സിംപ്ലിഫൈ ചെയ്യുക, ഇപ്പോൾ ഒരു ഫംഗ്ഷനകത്ത് വരും. Then we can evaluate that integral. Always the curve C is mod z equal to 1 in anti-clockwise sense. That's because our substitution is z is equal to ratio I theta. Okay. Then using residue theorem, we can evaluate the integral. This is the idea. Okay. Clear alle? Okay. Doubt illalla? Okay. Clear ആണെന്ന് വിചാരിക്കുന്നു. സോ ഇനി അപ്പോൾ ഞാനിത് നിങ്ങൾക്കൊരു അസൈൻമെൻ്റാണ് ഞാൻ തരാൻ ഉദ്ദേശിക്കുന്നത്. ഇനി ഒരു മെത്തഡ് കൂടി ഉണ്ട് നമുക്ക് കേട്ടോ, ഈ സെക്ഷനിൽ ഒരു മെത്തഡ് കൂടി ഉണ്ട്. ഇൻ്റഗ്രൽസ് ഓഫ് ദി ഫോം ഇൻ്റഗ്രൽ മൈനസ് ഇൻഫിനിറ്റി ടു പ്ലസ് ഇൻഫിനിറ്റി, ദേ ആർ കോൾഡ് ഇംപ്രോപ്പർ ഇൻ്റഗ്രൽസ്. അപ്പോൾ അത് നമുക്ക് അടുത്ത ക്ലാസ്സിൽ ഡിസ്കസ് ചെയ്യാം. കുറച്ച് കൂടുതൽ പ്രോബ്ലംസ് നിങ്ങൾക്ക് അസൈൻമെൻ്റ് ആയിട്ട് തരും. സോ ഇത് നിങ്ങൾക്ക് വരാൻ പോണ ഹോംവർക്കാണിത്. ഈ ഹോംവർക്കുകളെല്ലാം നിങ്ങൾ അസൈൻമെൻറ്റ് കൂടെ വെച്ചാൽ മതി. Integral 0 to 2 pi cos 2 theta by 5 plus 4 cos theta d theta. അതിൻ്റെ ഒരു ഹിൻറ്റ് ഞാനൊന്ന് ജസ്റ്റ് ഒന്ന് പറഞ്ഞു പോകാം, അതുകൊണ്ട് ഞാനിപ്പോൾ കാണിച്ചത്. ഈ റിസൾട്ട് is equal to e raised to I theta, then your one time is cos 2 theta, other one is cos theta. We know that what is cos theta. Cos theta is nothing. If z is equal to e raised to I theta, then cos theta is 1 by 2 into z plus 1 by z. Right? But what about cos 2 theta? We can evaluate cos 2 theta, we have to evaluate cos 2 theta in terms of z. Okay, this is the hint. If you take z equal to e raised to I theta, then what about z square? Z square is e raised to I2 theta, right? E raised to I theta square is e raised to I2 theta. And we know that e raised to I2 theta equal to cos 2 theta plus I sin 2 theta. ഇതാണ് എൻ്റെ ഹിൻഡ്. സോ എന്തായിരിക്കും cos 2 theta? പറയാവോ? വാട്ട് ഈസ് cos 2 theta? Z square is cos 2 theta plus I sin 2 theta. So what is cos 2 theta in terms of z?
1/2
Yes.
z square by 1 by z.
Z square
Plus 1 by
plus
1 by z. 1 by z square.
1 by
Z square.
z square വേണ്ടേ? Because z square is e raised to I2 theta. So what about 1 by z square? That is 1 by e raised to I2 theta. This is e raised to minus I2 theta. Okay, we know that what is e raised to minus theta? That is cos 2 theta minus I sin 2 theta. So that's why z square plus 1 by z square is 2 times cos 2 theta. Okay, that's why we take it 2. Okay, ഇനി നിങ്ങൾക്ക് എൻ്റെ ഹിൻഡ് ക്ലിയർ ആയെന്ന് വിചാരിക്കണം.